Okay, so astronomy is the study of very faint things that are very far away. Before the invention of the telescope, this was essentially the view of the universe, with the Earth at the centre, with the Sun, Moon and planets all orbiting it, and the stars as being a fixed background. When Galileo invented the astronomical telescope and turned it on the heavens, all of that changed. Science, and not only astronomy, and modern thought had a revolution called the Renaissance. The Earth was no longer at the very centre of the universe. It wasn't even at the centre of the solar system. It was just one of many planets going around a fairly average yellowish star in a fairly unimportant part of the universe. If you were to go out and look at the night sky in a dark site, you probably see this little gem. This is the constellation Orion, which you might recognise, and you might be lucky enough to see the fuzzy band of the Milky Way. But if you had a professional-grade telescope at a really great astronomical site, you could see something more like this, which is a lot more exciting, and you start to unlock the mysteries of the universe that you wouldn't normally see with your naked eyes, which is quite spectacular, really. But if you only have one telescope, and if you look carefully you can see Orion again, this is an all-sky camera in Hawaii at one of Las Cumbres Observatory's sites. You only get, with one telescope at one site, you only get one view of the night sky. So you need lots of telescopes all over the globe, in the northern and the southern hemisphere, so that you can look at the night sky any time of the day. If you space the telescopes out across the globe, you can spot fantastic astronomical phenomena as they happen. Like this before and after shot of a galaxy with a supernova explosion, an exploding star happening, marked by that little green tick that we managed to monitor continually for several months as it evolved. So you need to build telescopes. Now, the reason people haven't done this before is because it's quite difficult to build telescopes. You have to build big ones, like this one on the left, right down to little ones, like the one on the bottom right, which is about the same size as R2-D2. And then you need to put them in your back garden. Well, not your back garden, this is the back garden of Las Cumbres Observatory's headquarters, and you need to put them in an enclosure, and that looks like a typical enclosure, but the porticabins are also telescope enclosures for the little ones. But it's in a city. And as you can see from this, the view on the right is the light pollution, and the view on the left is what happens when there's a blackout. You can see all the fantastic stars, and you can see the Milky Way. So we put telescopes not in cities, but in fantastic astronomical locations across the world, like Cerro Tololo in Chile, which is at 11,000 feet, in a really dry atmosphere, above most of the cloud level, and a fantastic astronomical site, so that we can take best use of what we have. This is one of those bigger telescopes. It's the size of a double-decker bus. So imagine constructing that, hauling it up 11,000 feet, and making an enclosure that doesn't really look like anything you've seen, like some sort of sea creature. Sometimes you have accidents, and sometimes you might drop your occasional telescope mirror. This is just one of many challenges that faces people who want to build telescopes. But that's not the only challenge that you've got ahead of you. Once you've built the telescopes, you then have to put software in place so that all the telescopes can be controllable from anywhere in the world and talk to each other. Don't look too closely at that, that's just for illustration. That's our functional block diagram of what's going on. It's mind-blowing, but it's worth it. You get fantastic pictures like this. This was taken by the comedian Dara Breen with a telescope in Hawaii while he was sitting in London in his study during his lunch hour. But it's not only comedians that use these telescopes. We have professional astronomers using telescopes to monitor things like this. This is another exploding star, a supernova in the galaxy M51. You can see it marked out with a tick mark, which was monitored. It brightened, and then dimmed, and then brightened again, something which people weren't really expecting. In studying extrasolar planets, planets that are going around stars that aren't our own sun, they cause a tiny little dip of 2% in the star's brightness, and that's all we've got to find them. But if you think it's just professional scientists that can do this, then you're wrong, because it's a great time for people like yourselves who are interested maybe in science to get involved and analyse astronomical data. this is a project to do with looking at exoplanets, but there are many different projects like the Zooniverse and Galaxy Zoo and Moon Zoo. Now is a great time if you want to be an amateur astronomer or a citizen scientist